Hello, my name is Christine G, and I am going to be going over this problem about corn plants. And they randomly sample various types of plots. And the researcher wants to know whether the means of the plants for each plot type are equal. So here we're asked to write the null and alternative, and here the null is that the means are equal, and the alternative, at least one of the means is different. This looks on track to me, so let's check that. That looks good. And then state the requirements that must be satisfied for the one-way ANOVA procedure. So there must be k simple random samples, each from the same population. That's not true. The populations must have the same variance. That one looks good. There must be k simple random samples, one from each of k populations. That looks better. And we have to have the populations be normally distributed. K samples must be independent of each other, and then the populations must have the same mean. No, that's not true. Perfect. So now we're given this ANOVA table and asked to determine whether the null should be rejected or not. And we have the alpha level of significance, or rejection level, is at 0.05, and then our p-value is smaller than that, so it's 0.01. So this is down in the tail of the rejection area, so it's significantly away. Anything 0.05 or below is significantly far away from the null, which is in the middle, to reject it. So we reject the null. There is sufficient evidence to support the alternative. We'll check that one. Oh, reject the null. There is, I did the wrong box. There we go. That's the one I meant. And then here we have box plots that do these box plots support the results obtained in part C? Okay, so let's go ahead and take a look. It looks like one of these is significantly different. So yes, because the box plots show that the means are not significantly different. No, that wouldn't be it. Yes, because the box plots show that at least one of the means is significantly different. Perfect. And then here we need to use technology to make a normal probability plot of the residuals. So this is going to take some calculation. So let's open this in StatCrunch, and then we're going to have to calculate. So data, compute, expression, and we'll calculate these residuals. So we're going to build expressions. So sledge plot, and then minus, and then we go into the function. We want to get the mean sledge plot. And okay, and I hit OK. I've got to get, there's this extra m I put in there. Okay, now we got that, and we've got to do it for each one. So data, compute, expression, and then we'll build the spring disk next. And then minus m. I click M to get to the M faster. To get to the mean faster, sorry. So that's why I have to eliminate that M over here. Oh, and I typed the wrong thing. I need a minus, and then we'll compute that, and then we have one left. Compute, expression, and then no till, and then minus M. Oop, forgot that extra M. And StatCrunch will let you know if you do something like that wrong. Okay, so now we need to get them all in one column. So what I'm going to do is I do Shift and then Control Copy, and then here I do Control V. I should have said Control C and then Control V. So here I come down here, I hit Shift first and then I click it. So Control C and then Control V. Okay, so now I have them all under Sledge Plot, and I'm going to do a graph, QQ plot, Sledge Plot. Now I noticed that if I do it like this, I won't get the X and Y axis will be going the other way. So I click on Other Options, Normal Quantiles on the Y axis, and then I compute. And then let's take a look at these. So here we go. I'm going to make this, oh, I tried to move that. There we go. And then I'll just, this is A, and I'll just make it big. So let's see. Yeah, this looks like kind of the shape. Sometimes the line can be a little bit off. You know, not the same on both. So that to me looks, it doesn't have this. So let's go ahead and look at another one. And then let's see. I'm not making this all the way big. Okay, this looks different, like in here. So let's see. Go to part C. These two look good. Just like this, and then two more, and then two, and these look good. So yeah, I think that this one looks the best. So let's choose C and see what happens. Okay, perfect. And then, okay. How does the normal probability plot of the residuals show that the residuals are normally distributed? There is at least one outlier. No, the plot is not approximately linear. The plot is approximately linear. Perfect. And that is it. I hope this was helpful, and thanks so much for watching.